Hello friends, so today we will perform a finite element analysis design simulation, and in this video you will get to know about how to create FEM and simulation files. We will idealize geometry before meshing, how to create mesh collector. We will create a 3D mesh, then we will apply loads and constraints. We will check the model before solving, and the last we will solve the model and display the analysis results. So I hope you have a knowledge of what CIE is and other parameters. I'm not going into detail that what are the loads, what are the constraints. I hope you know these things if you are watching this video. Firstly, we will load the part on which we want to perform finite element analysis. Uh, when you after opening your part, you will see uh, the new FEM and simulation dialog box, in which you will see that it is creating two files named connecting rod fem2.fem and connecting rod sim2.sim. This simulation file and this is FEM file. I will make a video regarding this files, how many types of files are there in the design simulation in NX. They are interrelated with each other. Here there is optional option for create idealized part. So what happens if you work in idealized part, and what happens if you directly work on the this your part. So ideally, when you work on idealized part, it does not affect your master part. Okay, so here we will select solver and X master and design analysis type structural. Okay, then you will see another dialog box named solution. uh, you can rename it, and you can we have select the solver and X master and structural solution type. You have to select the linear static single constraint, and then click OK. After this, you can see we have here simulation navigator. Now in here you can see all the files: fm file, part file, mesh, control, polygon, geometry. There are various different nodes here, so we will discuss them when we will use them. So advanced role for this making this video, so do not get confused between things, like you are not getting this command or that command. Well, there is a similar here. You can see a simulation file view. You can directly save these files from here. Like right click and click save. The file will save automatically. You will see these two files will be created in your folder. So you can see here we have idealized file and FEM file. And like I have told you what we do in idealized file, we can do anything with the part without touching the master part, uh, in terms of changing its geometry and something like that. And connecting rod FEM, what we do in FEM file is like we will define material, and we do 3D mesh and etc. I will tell you when we will use these things. So first of all, I would like to work on idealized part, as I do not want to work on my master part. I do not want to change my master part for simulation, so it is better to work on idealized part. Go here, connecting rod FEM to right click, make display part. Ignore this warning for now. Click OK. Now, before we can modify the idealized part, we must place an associative copy of the master part file, an idealized part file. And how can we do this? Like we can use wavelink command, but in simulation we have a special command called promote. Okay, so it will promote the body, like just select it. Okay, that's it. And now I do not want these two holes, I do not want them in my part for doing analysis. So I will go here, idealize geometry. Here you will find the command idealize geometry. Select the part, idealize geometry. Sorry, here you will see the holes. Okay, here you will click holes, and when you will click OK, you will see that these holes are gone. So we have worked on our part. We have now we want to move to the FEM file, assign material. We have done our part in idealized part file. Now just go here, connect FEM file, make display part. You will see information window, just close it. Now you can see that we are getting geometry of what we updated in idealized part. And then we will assign material to our body. To assign material, just go to assign materials here and select the material which you want to assign to your part. Like I want to assign steel to my part. Select the part and click OK. Material is assigned. Now I'm going to create the 3D mesh for my part. So to create 3D mesh, just go here, tetrahedral, 3D tetrahedral. It creates a mesh of 4 and 10 noded tetrahedral elements. I will use 10. You can see here 4 and 10 type. Just select your body first, and then uh, C tetra 10. Select the element size. I am selecting 4 right now. Then click OK. Do nothing right now, just click OK. You can see 4 element size on a model, and 3D mesh is ready. You can see it here in the simulation navigator, 3D mesh. You can see it. Now we want to work on simulation file. We have created a 3D mesh, and just click on connecting rods into make display part. Now I do not want to work. I do not want to get into the 3D mesh now, right now. So just hide it so that you can work on the surfaces easily to apply loads and other things. Now in simulation file we will apply loads. So I'm applying bearing load here. You will go here, load type, you'll see here bearing. So click it, select the face, define the vector to specify the direction of load. Okay, I would like to bearing load on minus IC direction. I'm applying 1000 Newton load. Now the region angle is set to 180 degree. This means that the load will be applied over 180 degree of the cylindrical face. Click OK. Uh, this is you can modify the load display of this thing from here. You will go in the loads bearing, you go to edit display and just change the scale of the arrows. Click OK. See. Now we will apply a constraint on this curved surface. Which constraint I will apply? I will apply pin constraint. Just select your constraint, click OK. You will see that the constraints are applied and displayed, and cylindrical coordinate system is created by the constraint here. Now I will apply a second constraint because the part it is still free to rotate about z-axis of cylindrical coordinate system. So I will use another constraint at the top of part to prevent this rotation. Which constraint I will use? I will use user defined constraint. Just go here, select the, you can select here point, sorry, just select the point. Degree of freedom 1, I'm going to fix it, fixed, click OK. You can see the constraint is created. Now our next step is to check the model. And we have defined the mesh, material, loads and constraints. Now we are ready to solve the model. And we will verify that the model is ready to solve or not. Just go to this solution 1 in simulation navigator. This is the name we provided in the starting solution 1. Let's go model setup check. Here you can see there are no 0 error, 0 warning, 0 error, 0 warning. So we can solve. Okay, so here it is recommended more than 80% of elements in this model are 30 elements. Recommended that you turn on the element relative solver in the edit solution dialog box. Okay, so we will do this. You can solution 1, click edit, click element relative solver, click OK. just go on solution 1 again, click solve, click OK, and wait until the solution is complete. Okay. So the solution is complete. You want to go over, say no, close it, cancel it. Just go down in the simulation navigator. You will find the results option here, result node here. Right click or double click the structural. It will take you to the post processing navigator. Just down the simulation navigator, you can directly go to here without going here. So expand this structural node. Now here you will find all the analysis done by the NX solver. So I'm going to expand the trace element nodal, and I will check the one misses traces. Okay, here you can see the one misses trace. You can see the results here for different parameters like displacement nodal, y. You can see. So this is it. Thank you for watching the video. I will come up with more videos for different type of parts, and I will try to cover basic things soon. Thank you.